Fine. Can you see my screen?
Yes, sir.
So fine. Today we are going to talk about the Gauss's law. So Gauss's law basically, to define with the Gauss's law, I have to define, say, electric flux first. Electric flux. Electric flux. Basically, we know that from a electric field, that is from a positive charge, is radially outward, right? If you keep a positive charge, then the electric field line is going to be radially outward. So if you consider a surface over there, then not all of this electric field is not going to be penetrate that surface, right? Or that region. So we define that electric field line which going to penetrate some specific surface area, that we call basically say that electric flux. So remember this thing, say I draw, so this is a surface area, say this is actually the electric field line crossing. So you can say that these three, if I choose, so these three, we can say that is with the electric flux. This the electric field line which is not penetrate that some specific surface area, that we didn't say that the electric flux. So electric flux is basically the scalar quantity that we can find out by the formula actually. So electric flux, sometimes we also express by the phi E, S would be E dot A, right? Which is, we can say that the A is basically the area. We can write, say that EA cos theta, right? Since the dot product where it is the angle between the electric field and the area vector. And the area is a vector. You have that idea, right? Remember these things. So this is the electric flux when that both the electric field line and area are constant. In that case, say I have a surface. The area of this surface will be always perpendicular. This will be always perpendicular to that surface. Remember, either inward or perpendicular could be also that downward, right? Could be also that downward. This one actually we find out by the cross product. When you define, say you have that some region where say this is actually that A and B, say A defined by that length and B defined by that length, then the area we define basically length cross breadth, right? We use that cross sign over here, never use the dot. So length, area, breadth. Then that cross product we can find out, say that I express that area by a, say that A, which would be a vector, then this would be, say that A cross B. Now A cross B is a vector product, it has direction. That direction we can find out using that right hand rule. How do you find out? I put my forefinger in the direction of the first vector, then rotate towards the second vector, then that thumb will give me the direction of that resultant vector, right? Because we define that cross product, say that if we write down the A cross B, we already talked about this thing for the cross product, eta hat AB sine theta, right? Where this eta must be the perpendicular both A and B. It means that the direction of eta, say you have a vector A and B, which are, say that this is the vector A and this is the vector B, and the theta is angle between these two, and AB in the same plane actually. Then direction of this resultant vector must be toward that direction. This is be actually the direction of eta head, which that eta is perpendicular both A and B, and it could be also say that towards negative direction. So if you write down A cross B, if you put your forefinger towards that direction and rotate towards the second vector B, then your thumb would be towards the upward direction. So that's why this is the direction of the A cross B. But if you write down B cross A, that's when if you put your forefinger, sorry, so I can use the different color. So if you put your forefinger or index finger toward that direction and rotate towards the second vector A, then your thumb would be basically towards the downward direction. So that's why this is the direction the B cross A. They are in the two different directions. So that's why the area is a vector. That vector would be always perpendicular to the surface, either upward or the downward. So most of the case, basically we find out that direction of this area vector from inside to outside for a closed surface. Say if you think about, say I have a spherical shell. So I want to find out the area at this infinitesimal area, small, very small segment. Then it could be perpendicular toward that direction, and it could be also the perpendicular towards that direction. But I will take that one because the direction of we will consider is really from inside to outside. So this is will be outside direction, right? So every point on this sphere, it will be perpendicular that area vector actually. So that's why we will denote in that form. This is will be the direction of this area vector. It will be always perpendicular to that surface. Now, yes, sure.
So I have a question, sir. Sir, like I didn't understand like how could area be vector, sir? Like it's not pointing towards the direction, it's occupying a space in every direction, right? It's like the area of the circle, like how could there be a direction of the area of the circle? It's occupying in like 360, it's occupying space in 360 degree.
Yeah, I got your point. So how do we define that area of circle? It's a pi r square, right? We're talking about the rectangular case actually, where you're going to find out the area is a general formula. So you have a length and you have a breadth, right? In that case, we define the area basically length cross breadth, right?
Yes, sir.
So you use the cross product over here. Did you ever use the dot
In area.
in area?
So like we didn't do any calculation of area with like vectors with length 2, 3, like 2i
Yes.
plus 3j into
Yeah,
breadth.
yes, I know that one. Basically, we consider that one. Basically, most of the cases, it is basically that scalar, but that's not true. It is a vector. So once you write the cross product, so that's why they use the cross sign over here, the area.
Okay.
So it would be always is a vector quantity, the area over here.
Then according to the length and breadth, like according to the vector of that plane, we have to like find out which one is the length and which one is the breadth, or it will be like given.
Yeah, definitely. In that case, direction would be different. Say, if you think about, look at this, we have to use the right-hand rule to find out that one. Say, if you think about this is actually the length, right? So it could be your first vector, and this is would be your breadth. In that case, if you rotate, if you put your forefinger in that direction and rotate that towards the second vector, then your thumb would be towards the downward direction. Am I right?
Yes, sir.
if you consider the reverse way, say I put my forefinger in the direction of the second vector B and rotate towards second vector A, then my thumb would be towards the upward direction. So both cases they are perpendicular to that surface. So that's why we say that in the properties of the vector A cross B not equal to that B cross A. That is the
Yes, sir.
reason, because the A cross B, if it is upward, then the B cross A would be basically A cross B, basically the downward over here for this orientation, because this is my first vector. This is, if I rotate to the second vector, then this will be downward. But if I
Yes,
say
sir.
the B cross A, so this is actually A cross B vector, and this direction would be basically over here B cross A vector. We talk
Yes,
about
sir.
this thing in the case of the physics triplet, the geometrical representation of dot product and the cross product, vector dot product and the cross product.
Yes, sir.
Okay.
Yes, sir.
Okay, fine. So, so that's why. So that's why when you write that phi is the electric flux, which is a scalar quantity basically, EA cos theta. Theta must be angle between your area vector. Say I'm considering this case. Say this is my area. Its area must be towards perpendicular to that direction, right? I'll choose. So this is to be my area vector A. So electric field direction could be in different direction, right? It could be parallel to that plane. If it is parallel, then what is the angle?
So 90 degrees. So parallel will be, sir, 0 degree.
No. Parallel means to the surface. I draw. Say this is the electric field
Oh,
direction.
okay. Then say it will
Then
be
angle
90.
is what? This 90. Then what will be the phi? Cos 90 is
Cos 90 is 0.
0. So electric flux will be the 0 in that case. Why? Because this electric field line is not going to penetrate that surface area. So that's why it's not going to the flux. To any electric field line which is not going to penetrate some particular region, we cannot say that with the flux. To be flux, definitely it could be must penetrate the surface area. Say I'm going to say that this is the electric field line. Then this field line is going to penetrate that surface area, right? I can draw it 3D way. So what would be that? So I'm going to use different color. So this one, say that electric field line is that way, is coming from to the lower part to the inside to outside. Then it is actually basically penetrating, right? Penetrating that area. So then we can say that this would be actually the flux, and say this is going to be the angle that create with the area is theta. Then we can say that this is to be the electric flux. We can calculate it using this formula.
So, sir, the direction of the area would be, sir, perpendicular to the plane. Is that, sir? Because
always, yes, it will be always perpendicular to the plane actually. So instead of say, what would be happen inside, say, if I consider a spherical shell. So for the in that case, say I will take a infinitesimal area in that case. Say that one, right? I can consider. So in that case, this area would be over here into that direction. If you consider that portion, area would be over that direction because it is perpendicular to that point. If you consider over that, that would be towards that direction.
Yes.
So if you add them together, you will find out the total area of the spherical shell, right? So area would be always perpendicular to that surface. Remember this thing. This is a very important point for this Gauss's law. Fine. So let's move to the second case. So when say that this field is variable, in that case, how I'm going to find out that flux? Basically, I'm going to integrate. I will choose a closed surface, E dot, or say the area is variable. Sometime we will find out area is a function of something parameter. Then we will find out the electric flux using that formula. We can find out in that way, this electric flux. So now said Gauss's law is state that, which is very important law, or you can say that this is the heart of this course actually, this principle of physics 2. He said that if you consider a closed Gaussian surface around an object, say I have any shape of object, say I consider a box, say this is a box, and I'm going to find out, say what will be the flux. I could find out what the electric field. So say this is my Gaussian closed surface, which is going to be the enclose that total box over here. In that case, we can find out that electric flux using that formula, E dot dA must be equal to Q enclosed divided by epsilon naught. So Q enclosed basically the total charge, total enclosed charge by this Gaussian surface. This is actually the Gauss's law we find out for this electric field. We'll also find out some Gauss's law for magnetic field. That one we will talk about in the later. So this, I write down, look at this is a summation sign. Say if there is more than one charge over here, say it could be say Q1, some charge, you will find out, say that minus Q, there would be say that plus, say that this is the plus Q2, then the total charge, or you can say that this is Q minus Q1. Then total charge, net charge would be sum of this, right? I will write down say Q1 plus Q2 minus Q1. I'll find out basically the plus Q2 would be the total charge. That's the meaning of summation of these charge. And this epsilon naught is a constant, right? So that's how actually we can find out the enclosed charge or the electric flux. And remember, since this electric flux is a scalar quantity, it's a dot product, we find out from that, right? So over here, so this is actually the dot product, or you can also find out from that equation, it is also the dot product. So that's why this electric flux could be basically greater than 0, it could be less than 0, and it could be also that equal to the 0. It would be basically a scalar quantity, it could be a number. Sometimes you will find out that positive quantity, sometimes you will find out the negative quantity, and sometimes you will find out that the net flux is basically the 0. So net flux 0 means, I'm starting from that. So net flux 0 means whatever that electric field line is coming into that surface area, it exactly all the field line is passing through. Incoming and outgoing basically the equal. So that's why the net flux would be the 0. If it is positive, so if it is the positive, then I could assume that there will be some positive source charge inside that surface area or inside that region. If it's negative, then I will assume that there will be some negative source charge inside that region. We can explain this thing from there because we find that phi is basically Q enclosed divided by epsilon naught, right? If phi is negative, this is constant. So phi is negative, multiply that quantity, you will find out a negative quantity. That's mean I can say this enclosed charge should be something negative quantity. It means that in that region there will be some negative source charge. That's the meaning of that if the flux is negative. If the flux is positive, I'll assume that there will be some positive source charge inside that box or inside that region actually. We explain in that way actually the meaning of that flux positive, negative number. Okay, fine. So let's calculate some flux for some case. Say I have a box it's a cube. You can consider. So that cube has a ace length. Actually, say that the 2 meter for simplicity calculation I'm taking. And I'm to say that a electric field E is towards that direction. Say that the magnitude of this electric field, or in terms of vector, I can write, say 500 Newton per Coulomb. Say I choose, say this is my positive X direction and this is my positive Y direction. Now I want to find out that flux for each of these surface for this cube. Calculate the, I should say the net flux for the cube. I use the net flux. Fine. To calculate that flux, basically, what I have to do, look at this. Over here, both actually that your electric field and the area must be the constant. What will be the area of this cube? So cube has 6 faces, right? Sorry. I need to draw a bigger way so that it's easier. How many faces of a cube? You have a 6 face. I'm going to label that one, that 6 face also. So consider this. Right. So there are 6 faces of this cube actually. Say we can say this one actually say that top surface, or I can label, say this is S1, this is S2 with the bottom surface. I'm using different colors so that we can understand. Then I choose this surface, actually that 3 left, this one is right, or I can use that SR, right surface, this is the left surface, SL, and this is ST top surface, and say this is actually bottom surface. So I can use different color. So this one, so this one say that front surface, and that one say that back surface. And right, and the is back. There are 6 surfaces, right? Now all, since it's a cube, all the surface has area which would be basically a square. Am I right? That's when it's going to be that 4 meter square. This is the magnitude, right? Now I have to find out that this area, all that direction, because it's a vector. So say first I'm going to find out that area with that top surface. I'll write, say that A into, which is I have to give the direction. The top surface say would be which direction. If I consider say in the 3D case, say I'm considering, say this is my X direction. Say this is, I use that Y direction, and this is actually the, say the Z direction. So what will be that area? I said that area of the top surface would be perpendicular to that surface, right? So this is would be towards that direction. It means it will be towards that Y direction. Then I can write this top surface area would be basically A into Z hat. So I'll write down 4 Z hat meter square. Can I write this one? By the same analogy, I can write, say, bottom surface would be minus 4 J hat meter square. Do you understand this thing? This is very important to understand or calculate the flux for different shape of object. Then what about, say, that right surface? Right surface towards that positive X direction, because area of this right surface would be perpendicular, that right surface would be toward that direction. Then I can write it be 4 I hat meter square. Area of the left surface would be minus 4 I hat meter square. And area for the front surface would be 4 K hat meter square. And area for the back surface would be minus 4 K hat meter square. I just separated all that area, because what I'm going to do, I'm going to find out that net flux would be algebraic sum of the flux by these 6 surfaces, say top surface plus flux by the bottom surface plus flux by the right surface plus flux by the left surface plus flux by the front surface plus flux by the back surface, right? That would be my total flux, electric flux for this cube.
Sir,
Yes.
sir, how did you determine the direction would be positive or negative? Like if it is only a plane, so if it's going outside or downwards, sir, where will be that vector written of length and breadth?
Yeah, look at this. I use, this is my reference axis, right?
Yes, sir. Yes, sir.
So according to that, I label that area direction. Now your question is, why this area towards that rightward for that surface?
Yes, sir.
Right. I
Yes.
say, look at this. When we are going to find out this area for this shape of object, I will consider the direction will be always from inside to outside.
Okay, sir. For 3D objects.
Yeah, for 3D object. This will be always from inside to outside.
But like, what about, sir, for a plane, for a like 2D plane?
Yeah, exactly. So you can consider this 2D plane. So that's why I'm saying that it is 2D plane. So that could be possibility in that direction, and it could be also downward direction.
Yes, sir.
So that depends. If you take, so this is your first vector and this is your second vector. This one would be basically, say that B cross A, right?
Then we'll find the magnitude.
This one would be, yeah, and this one would be basically A cross B direction using the right hand rule.
So the thumb will point the direction of the area.
Area, exactly. That's the right hand rule actually. Put your forefinger in the direction of the first vector and rotate toward the second vector. Then thumb will give you the direction of your resultant vector or the area vector over here.
Okay, sir.
This is the application of the vector in this course. Throughout this course, we will only apply the vector knowledge. This is only the vector algebra. You can say that. Okay,
Yes.
fine. So that that should be my basically that net flux, right? If
Yes,
you
sir.
are very expert, then without calculation of this one, you can say that what will be the net flux of this case actually. Can anyone guess what will be the net flux? Whatever I say, on the basis of that, it can
So
be said.
0.
It would be zero. Very good. It would be zero. Why is zero? Can you say?
So because right side is balancing left side and left side, like upward is balance, but like all the cubes of opposite side are balancing each other, all the planes.
Yeah. So if you think about, look at this, you're very close to your answer. So if you think about the electric field is toward that direction, then this electric field line only penetrated your left surface and the right surface,
Yes, sir.
right? No other
Yes, sir.
surface, front, back, top, and bottom is not going to penetrate,
Yes, sir.
right? Then that electric flux for that surface, top, bottom, front, back, would be basically the zero. So we say that the electric field line which are going to penetrate that surface, that we will consider the electric flux. Otherwise not. Since the electric field line, basically this one is penetrate only this surface and that surface. Other than they are not going to penetrate. So I can say the electric flux for that surface, rest of say the top, bottom, front, and back would be the zero. This is physics. Mathematically, we can prove that also, that one. So how it's become to the zero. Look at this. First, I'm going to find out that electric flux for the top surface. So what equation I'll write? I'll write down E dot A top, right? This is
Yes,
my
sir.
formula too. So what is E? E is, look at this, E is 500 I hat. 500 I hat. What is ET, top surface? Is a 4 J hat, right?
Yes, sir.
4 J hat. So it should be 2000 I dot J. What is the value of I dot J?
So I dot J is 1.
I dot J equal to 1.
0, 0, sir.
It's a 0. It's a 0. So that's why the phi top would be is basically the 0. Look, I said that the flux for this top surface must be going to be the 0 because this electric field line is not going to penetrate. Similarly, I can also find out, say that bottom surface, you should do that. So otherwise you will be in difficult position. This is very interesting thing. For the bottom surface, I'll write down E dot AT is going to be that E is my 500 I head dot bottom surface is minus 4 J head, right? Look at
Yes,
this.
sir.
This is my bottom. Then again, it's going to be the minus 200, sorry, 2000 I dot J. That's going to be the 0.
0. Yes.
Now you can find out the front surface also, E dot EF. So it's a 500 I head dot front is 4 K head, right? This is going to be 200 into I dot K. That's going to be the 0. I'm finding out mathematically this one. And back surface, it would be E dot, oh, I'm sorry, your time is over. Can you give me 5 minutes extra
Yes, sir.
so that I can finish that one? So A back is going to be the 500 I head dot minus 4K head. Again, it's a minus 2000 I dot K. That must be going to be the 0, right?
So what? Yes, sir. What will be said about the eyes? 4i.
4I. Yeah, I'm going to
Right.
do that. Yeah.
Yes.
So I'm going to find out, say that right now, say that right surface. So E dot AR, the area for the right surface, which is 500 I head dot for the right surface. Look at this, is a 4 I head, right?
Sir.
This one.
Yes, sir.
So 400 I head. So that's when you will find out 2000 I dot I. So what is I dot I?
So 1.
It's a 1. So I'll find out 2000 over here. And the unit of this flux, actually, remember, Newton meter square per coulomb. This will be
Okay.
plus 2000. What about, say, that lead surface? I'll find out E dot I A left, which will be 500 I hat dot minus
Minus
4I,
4.
right? So it will be
Yes.
give me 2000 I dot I, which I'll find out minus 2000 Newton meter square per coulomb. Now, if I add all them together, these are the 0, this plus 2000 and minus 2000. That would be that
0.
cancel over, right? This is going to be the 0. So phi net in that case, 0 plus 0 plus 0 plus 0, top, bottom, front, back, plus right, which is 2000 minus 2000. That's going to be the 0. So that's why this net flux for by this Q would be basically the 0. Why it is 0, you can explain in another way actually from there. Whatever the electric field line actually they are coming into that surface, it is also outgoing from the other side. So that means there are no scope to pile up this electric field line inside that cube actually, since there are no charges. So that's why you find out that net flux by this cube would be basically the 0. That's why I'm asking you. Without doing that calculation, you can also say that if you closely observe, it can be said that whether the what with the flux for this case actually.
So, but like after we did the scalar product,
Yeah.
so we got negative. Then,
Yeah.
sir, won't that negative tell it is a vector, or it's just like
flux is a scalar quantity, right?
yes, sir.
So it cannot be vector.
So like we got minus 200 and 200. So that
Yeah.
what does that minus 2000 mean?
If you say that both are negative over there, right? Then it would be a phi net would be your minus 4000.
Yes, sir.
So that's a flux. It's only the number minus 4000 Newton meter square per coulomb. In that case, there will be a possibility inside that box there will be a negative source charge. That's
Okay.
how you find out the flux is negative.
Okay.
That is the meaning of this flux actually. All right, guys. Today is your time is up. I'm sorry for today. Basically, in the beginning, my network connection was unstable. I'm trying. After half an hour, I could reestablish my connection. So that's why I come back to again. But in the previous class, actually, the Sunday, no one was in the class. I was waiting 1 hour and 20 minutes. After that, I leave that your class. But no one is present over there. So if you don't
I
come,
am from different sections.
You are from different section? Which section?
Sir, section 10.
Section 10. Who is the course teacher of the section 10?
Mosadios, sir.
Oh, anyway, fine. So the problem, look at this, because I have to start the Gauss's law today, right? Why I do that? Basically, I have a plan to do that electric dipole in the previous Sunday actually, but no one is present. So my request is go through that video material if you need that some class on the electric dipole. So I'll give you a review class actually on that.
Sir,
But you have to go through that.
Sir, I did all the suggested problems that included continuous charge distribution and dipole. And
Yeah,
so
fine.
like I was struggling with some problems, so like that's why I came here.
Okay, fine. Then what you can do actually, you can ask some particular problem on that. I can discuss with you.
So when, sir, like the class is over now?
Yeah. Do you want to continue right now?
So I don't have any problem. Like I don't have any class, but
so it should be
know
better to what I can say,
if you
because
are
I have a no, I have a meeting today actually.
okay, sir. Okay.
So
like, and if you can tell me a time, then sir, I will come. Then like
you can do one thing. You can come in the next Sunday, or
so
Sunday
like
will be
next.
too late. It will be too late for you if you.
I don't know, sir, because like everything in physics is pacing so fast, sir. Now we are doing Gauss's law. I haven't like touched the sample problem, the suggested problems from 23 yet. I'm still stuck at 22 from week 2.
22. Oh, then okay, fine. So no. One thing actually, we are uploading that sample problem also in the VUX, right?
Yes,
Did
sir.
you go
Sir,
through?
like yes, sir. Like in the in live classes, you know, if it was in on-campus classes, I could have asked question, why did you do this in the math or something like that? Because
Yeah,
like I
definitely.
had some technical issues, like some problems why you are doing this and then why you are differentiating with this. Like I need to know how why you are going with that approach.
Yeah, definitely. You can ask that one also in the live seminar. So if you have any problem, you can ask to that course teacher, or you can ask that the teacher who is creating that video. You can ask that one
Yes, sir.
also. You have.
So like
Okay,
then,
fine. I can give you the 30 minutes right now today.
okay, sir. So okay, that will be
What
really
about
good.
what about yeah? What about others?
So there is none, I guess.
No, one is that Sabrina. Sabrina, are you listening me? So do you have any more question? Okay, if you want to stay, you can stay, or if you want to leave, you can go actually. Okay, Asif, I'm going to stop the recording.
Okay, sir.